I.S. Barber. 60-Day Rapid Revision, Rare, Series. UPSC IAS Prelims 2022. Daily Handouts. Day 5, Topics 1. Higgs Boson 2. High Luminosity LHC, HLLHC, 3. Matter versus Antimatter versus Dark Matter 4. Standard Particulate Model 5. Neutrino Observatory in India. 6. Lucy mission of NASA. 7. Eco-satellites of NASA. 8. ISRO's Chandrayaan 1, 2, 3, 9. NASA's Viper mission 10. 2-deoxy-D-glucose approved by DGCI 11. Israel's Iron Dome rocket defense system 12. Ambity AG 13. Largest collection of fast radio bursts, FRBs, catalog 14. NASA's Viva mission 15. Envision mission. IASBABA's 60 Days Rapid Revision Series, Rare, Notes, Day 5, Science and Technology. 1. Higgs boson. What is Standard Model? The Standard Model is a theory of particle physics. The theory describes three of the four known fundamental forces, the strong force, the weak force and the electromagnetic force in the universe, as well as classifies all known elementary particles. It says all the material around us is made up of 12 matter particles, also known as fermions. The other 11 particles predicted by the model have been found and only Higgs particle was not yet found, so the CERN was trying to find it. Higgs boson particle. This particle is theoretically responsible for mass, without which there would be no gravity and no universe. Therefore it is also called the God particle. The Higgs particle was proposed in the 1960s by British physicist Peter Higgs as a way of explaining why other particles have mass. In 2012, the ATLAS and CMS experiments at CERN's Large Hadron Collider announced they had each observed a new particle around 125 GeV called Higgs boson. The Higgs boson was detected by studying collisions of particles at different energies. Higgs boson decays to fundamental particles known as bottom quarks. 2. High Luminosity LHC, HLLHC. CERN, the European Organization for Nuclear Research, recently found that Higgs boson decays to fundamental particles known as bottom quarks. Testing this and understanding more particles require an upgradation to the Large Hadron Collider, i.e., High Luminosity, HL_LHC. Why and how to study particles? Particle physics probes nature at extreme scales to understand the fundamental constituents of matter. Particles communicate with each other in accordance with certain rules. These are embedded in what are known as the four fundamental interactions. The Large Hadron Collider, LHC, is the world's largest and most powerful particle accelerator, an apparatus for accelerating subatomic particles to high velocities by means of electric or electromagnetic fields. How? Protons are collected in bunches. They are then accelerated to nearly the speed of light and made to collide. Many particles emerge from such a collision, termed as an event. The emergent particles exhibit an apparently random pattern. But they follow the underlying laws that govern part of their behavior. Studying the patterns in the emission of these particles help understand the properties and structure of particles. CERN has thus announced that it is getting a massive upgrade to the LHC. This will be completed by 2026. Large Hadron Collider High Luminosity LHC. Why an upgrade to High Luminosity LHC, HLLHC? Luminosity is a measure of the number of protons crossing per unit area per unit time. So upgrading, increasing the luminosity, will increase the rate of collisions. Eventually, the probability of most rare events will also increase. This offers scope for studying the properties of newly discovered particle and its effect on all other particles. Understanding the properties of the Higgs boson will require their abundant supply. And also, Standard Model has its shortcomings, and there are alternative models that fill these gaps. It thus necessitates a High Luminosity LHC, HLLHC. How will it help? The beam in the LHC has about 2,800 bunches, each of which contains about 115 billion protons. The HLLHC will have about 170 billion protons in each bunch, contributing to an increase in luminosity. After the upgrade, the total number of Higgs bosons produced in 1 year may be about 5 times the number produced currently. The experiments will be able to record about 25 times more data in the same period as for LHC running. 3. Matter versus Antimatter versus Dark Matter. Matter. The matter is made up of very tiny particles, and these particles are so small that we cannot see them with naked eyes. It has been observed that matter exists in nature in different forms. Some substances are rigid and have a fixed shape, wood. Some substances can flow and take the shape, water, while there are forms of matter that do not have definite shape, air. States of matter. 1. Solid 2. Liquid 3. Gas 4. Plasma. 5. Bose-Einstein condensate. Plasma is a not so generally seen form of matter. Plasma consists of particles with extremely high kinetic energy. Electricity is used to ionize noble gases and make glowing signs, which is essentially plasma. Superheated forms of plasma are what stars are. Bose-Einstein condensates. This exotic material only exists when atoms of certain elements are cooled to temperatures near absolute zero. At that point, clusters of atoms begin functioning as a single quantum object with both wave and particle properties. Since there is almost no kinetic energy being transferred from one atom to another, the atoms begin to clump together. There are no longer thousands of separate atoms, just one superatom. This form of matter was predicted in 1924 by Albert Einstein on the basis of the quantum formulations of the Indian physicist Satyendra Nath Bose. Antimatter. Anti means the opposite. So antimatter has some properties opposite with respect to the usual matter. Antimatter is defined as matter composed of the antiparticles, or partners, of the corresponding particles in ordinary matter. Antimatter particles share the same mass as their matter counterparts, but qualities such as electric charge are opposite. The positively charged positron, for example, is the antiparticle to the negatively charged electron. Matter and antimatter particles are always produced as a pair and, if they come in contact, annihilate one another, leaving behind pure energy. The Big Bang should have created equal amounts of matter and antimatter in the early universe. Comparatively, there is not much antimatter to be found. Something must have happened to tip the balance. One of the greatest challenges in physics is to figure out what happened to the antimatter, or why we see an asymmetry between matter and antimatter. Dark matter and dark energy. Dark energy is an unknown form of energy that is tending to accelerate the expansion of the universe. Dark energy is a repulsive force, a sort of antigravity, that drives the universe's ever-accelerating expansion. Dark energy is the far more dominant force of the two, accounting for roughly 68% of the universe's total mass and energy. Dark matter. The majority of dark matter is thought to be composed of some as yet undiscovered subatomic particles. Dark matter works like an attractive force, a kind of cosmic cement that holds our universe together. The name dark matter refers to the fact that it does not appear to interact with observable electromagnetic radiation, such as light. It is thus invisible, or dark, to the entire electromagnetic spectrum, making it extremely difficult to detect. Dark matter interacts with the rest of the universe only through its gravity, that's how we know it exists. The material is considered to be a matter since it has gravitational attraction, and it is dark because it does not seem to interact with light, or any part of the electromagnetic spectrum. 4. Standard particulate model. Particle physics probes nature at extreme scales to understand the fundamental constituents of matter. Particles communicate with each other in accordance with certain rules. These are embedded in what are known as the four fundamental interactions. The particles and three of these interactions are successfully described by a unified approach known as the Standard Model, SM. The Standard Model is a set of mathematical formulae and measurements describing elementary particles and their interactions. Standard Model categorizes the elementary particles, fermions and bosons. Developed in stages starting in the early 1970s, the model combined what was known about particles and forces at the time to develop a fully consistent quantum theory on matter. It also predicted the existence of yet-to-be-discovered particles, such as the Higgs boson. Particle families. The Standard Model categorizes fundamental particles into related groups, as seen in the table below. Fermion. A fermion is a category of elementary particles. They are very small and very light. Fermions can be thought of as the building blocks of matter because atoms are made up of fermions. Fermions can be classed further into quarks and leptons. Fermion quarks combine into the more familiar protons and neutrons. Leptons include electrons, which hover around the nucleus of atoms. Bosons. These are the whispers that keep fermions in touch, mediating forces that bind and repel matter. They include photons, gluons, W and Z bosons and Higgs particle. Drawbacks of Standard Model: it is struggling to incorporate general relativity's description of gravity. And also, to tell us why the universe is expanding ever faster, or explain why there is more matter than antimatter. 5. Neutrino Observatory in India. Neutrinos. Proton, neutron, and electron are tiny particles that make up atoms. The neutrino is also a tiny elementary particle, but it is not part of the atom. A neutrino is a subatomic particle that is very similar to an electron but has no electrical charge and a very small mass, which might even be zero. There are actually three kinds of neutrinos: the electron neutrino, the muon neutrino, and the tau neutrino. Neutrinos are one of the most abundant particles in the universe. Because they have very little interaction with matter, however, they are incredibly difficult to detect. It interacts very weakly with other matter particles. Neutrinos come from the sun, solar neutrinos, and other stars, cosmic rays, etc. They can also be produced in the lab. The INO will study atmospheric neutrinos only. India-based Neutrino Observatory, INO project is aimed at building a world-class underground laboratory with a rock cover to conduct basic research on neutrino. Location: proposed to be constructed in the Bodhi West Hills, Theni district, of Tamil Nadu. The Tata Institute of Fundamental Research is the nodal institution. The observatory is to be built jointly with the Department of Atomic Energy and the Department of Science and Technology. The observatory will be located underground so as to provide adequate shielding to the neutrino detector from cosmic background radiation. The operation of INO will have no release of radioactive or toxic substances. Applications of neutrino science. 1. Properties of the Sun. Properties of the Sun. Studying these neutrinos can help us understand what goes on in the interior of the Sun. 2. Constituents of the universe. If the properties of neutrinos are understood better, they can be used in astronomy to discover what the universe is made up of. 3. Probing early universe. Neutrinos interact very little with the matter around them, so they travel long distances uninterrupted. These undamaged messengers can give us a clue about the origin of the universe and the early stages of the infant universe, soon after the Big Bang. 4. Medical imaging. There are technological applications of the detectors that will be used to study them. For instance, X-ray machines, MRI scans, etc., all came out of research into particle detectors. Hence the INO detectors may have applications in medical imaging. 6. Lucy mission of NASA. Lucy mission by National Aeronautics and Space Administration, NASA, will be the first ever space mission to study the Trojan asteroids. The Trojan asteroids, also known as Jupiter Trojans, are a population of primitive asteroids orbiting in tandem with Jupiter. The Trojan asteroids are rocky worlds as old as our solar system and thought to be remnants of the primordial material that formed the outer planets. The Lucy space probe launched in 2021 will be on a 12-year voyage to Jupiter's orbit. The mission takes its name from the fossilized human ancestor, Lucy, whose skeleton provided unique insight into humanity's evolution. The Lucy mission will revolutionize our knowledge of planetary origins and the formation of the solar system. 7. Eco-satellites of NASA. NASA tested an eco-friendly fuel and a compatible propulsion system in space for the first time with the Green Propellant Infusion mission on a SpaceX Falcon Heavy rocket. A non-toxic rose-colored liquid could fuel the future in space. This green fuel is developed by the Air Force Research Laboratory in California. The green propellant is a blend of hydroxyl ammonium nitrate with an oxidizer allowing to burn. The green fuel can be an alternative to hydrazine, the highly toxic fuel commonly used by spacecraft. The green fuel is denser than hydrazine and offers nearly 50% better performance. 8. ISRO's Chandrayaan-1, 2, 3. Chandrayaan-1. Chandrayaan-1 is the India's first mission to Moon. Was launched successfully in 2008 from Sriharikota with a mission life of 2 years. It was launched using PSLV-C-11 vehicle and it successfully completed all its major objectives. The satellite made more than 3,400 orbits around the Moon and the mission was concluded when the communication with the spacecraft was lost in late 2009. Chandrayaan-2. Chandrayaan-2 is India's second lunar exploration mission after Chandrayaan-1. Chandrayaan-2 mission is a highly complex mission which brought together a lunar orbiter, lander named Vikram and rover named Prajan. The goal of the mission was to explore the southern pole of the Moon, which no other lunar mission in the world has explored. It also aimed to map and study the variations in lunar surface composition, as well as the location and abundance of lunar water. It was launched in 2019 using the GSLV Mk3, which is India's most powerful launcher to date and has been completely designed and fabricated within the country. The lander Vikram's failure on a soft landing resulted in hindering the attempt of rover Pragyan to travel on the Moon. Chandrayaan-3. Chandrayaan-3 will take its flight in 2022 into outer space with a rover and lander to reattempt the landing on Moon. It will not include any orbiter like Chandrayaan-2. It aims to examine the Moon's surface, especially areas that have not been receiving sunlight in some billion years. This exploration will not limit to the surface but aim to study the subsurface and exosphere. 9. NASA's Viper mission. National Aeronautics and Space Administration's, NASA's, Volatiles Investigating Polar Exploration Rover, or Viper, is a mobile robot that will go to the south pole of the Moon. It will help obtain a close-up view of the location and concentration of water ice that could eventually be harvested to sustain human exploration on the Moon, Mars, and beyond. NASA is undertaking the mission to understand if it is possible for human life to sustain there, by using locally available resources. Viper represents the first resource mapping mission on another celestial body. Viper is planned for delivery to the lunar surface in 2023 under NASA's Commercial Lunar Payload Services (CLPS) program. 10. 2-deoxy-D-glucose approved by DGCI. The Drugs Controller General of India, DCGI, approved the emergency use of drug 2-deoxy-D-glucose, 2-DG, in moderate to severe COVID-19 patients. The drug has been developed by Institute of Nuclear Medicine and Allied Sciences, INMAS, a lab of Defense Research and Development Organization, DRDO, in collaboration with Dr. Reddy's Laboratories, DRL, Hyderabad. Clinical trial results have shown that this molecule helps in faster recovery of hospitalized patients and reduces supplemental oxygen dependence. The drug comes in powder form in sachet, which is taken orally by dissolving it in water. Its selective accumulation in virally infected cells makes this drug unique. 11. Israel's Iron Dome rocket defense system. Iron Dome is a multi-mission system capable of intercepting rockets, artillery, mortars, aircraft, helicopters, and unmanned aerial vehicles, UAV. The system's capability is exhibited only over short ranges of up to 70 kilometers. It is an all-weather system and can engage multiple targets simultaneously and be deployed over land and sea. One of the system's important advantages is its ability to identify the anticipated point of impact of the threatening rocket. The system has intercepted thousands of rockets so far and the success rate is over 90%. The Iron Dome has three main systems that work together to provide a shield over the area where it is deployed, which are: radar. It has a detection and tracking radar to spot any incoming threats. Weapon control. It has a battle management and weapon control system, BMC. Missile fire. It also has a missile firing unit. The BMC basically liaises between the radar and the interceptor missile. 12. AMBER-TAG. AMBER-TAG, developed by IIT Ropar, Punjab, is India's first indigenous temperature data logger for cold chain management. AMBER-TAG is a first-of-its-kind Internet of Things (IoT) device that records real-time ambient temperature during the transportation of perishable products, vaccines, and even body organs and blood. The device has been developed under Technology Innovation Hub, AWADH, Agriculture and Water Technology Development Hub, which is a Govt of India project. It is shaped as a USB device. AMBER-TAG continuously records the temperature of its immediate surroundings from -40 to +80 degrees in any time zone for a full 90 days on a single charge. That recorded temperature further helps to know whether that particular item transported from anywhere in the world is still usable or perished because of temperature variation. 13. Largest collection of fast radio bursts, FRBs, catalog. Fast radio bursts, FRBs, are the bright bursts of radio waves whose durations lie in the millisecond scale. It is difficult to detect them and determine their position in the sky due to their durations in the milliseconds. In 2020, NASA spotted FRBs for the first time in the Milky Way. Researchers from the Pune-based Tata Institute for Fundamental Research, TIFR, and the National Center for Radio Astrophysics, NCI, have assembled the largest collection of fast radio bursts, FRBs, catalog. The catalog can be used to understand the three-dimensional structure of matter in the universe. The data for this catalog is derived from the Canadian Hydrogen Intensity Mapping Experiment, CHIME. 14. NASA's Psyche mission. NASA will launch the Psyche mission in the late 2022, which will study a large metal-rich asteroid known as 16 Psyche in the main asteroid belt. The asteroid is present in the main belt between Mars and Jupiter. The asteroid Psyche is an uncharted world in outer space. What we know about the asteroid is that it's shaped somewhat like a potato and that it spins on its side. This asteroid is made up of large and dense metallic objects, which is unlikely to the regular asteroids, which are made up of rocks or ice. The main aim of the Psyche mission is to analyze if the asteroid is actually a part of a lost planet and holds similar properties and elements. The Psyche spacecraft shall land on the asteroid by early 2026. Over 21 months in orbit, the spacecraft will map and study 16 Psyche's properties using a multispectral imager, a gamma ray and neutron spectrometer, a magnetometer, and a radio instrument. 15. Envision mission. Envision mission is a mission of European Space Agency (ESA) to study the Venus and its past. The mission will provide a holistic view of Venus from its inner core to upper atmosphere. Envision will tell us the history Venus experienced that drove it from being habitable to hellish. It will help us to determine how and why Venus and Earth evolved so differently. The Envision mission is likely to be launched sometime in the 2030s. The spacecraft will take about 15 months to reach Venus after it is launched. To achieve orbit circularization, another 16 months will be required. Another ESA-led mission to Venus called Venus Expresses, 2005 to 2014, will lead the Envision mission.